In this video, we're going to take a look at how we can use Excel to generate the Poisson uh, probability values, both the PDF and the CDF. And I would say of all the distributions, and it's not surprising when you look at even the formulas that we would use if we were doing this by hand, the Poisson PDF, it's the simplest one. It's the simplest one in terms of evaluating, but it does pose some difficulty because your lambda technically can be any positive number and the sample space is countably infinite, right? So because of those, not really constraints, but just those realities, you end up having limited tables again to rely on, right? But again, software like Excel and other more sophisticated software packages can generate the values that we need that can't be listed in any finite table, right? So in this example, I'm going to show you how to, just generate some possible values because again, once the sample space is countably infinite, yes, Excel can generate lots and lots of values, but it still can't generate them all. So we're just going to generate some of the possible values and then show you how to use the built-in Excel function to generate the PDF values for the Poisson distribution and then the CDF values, again, for the same. So let's start with our sample space. So I'm going to utilize a sequence function in Excel, and it's literally called sequence, and it will allow us to generate values that follow a particular pattern, and we can store it in rows and columns and so forth. We just need it in one column, right? So I'm going to highlight cell A3. That's where I'm going to put the smallest possible value of x. Go up to our formula bar, start with the equal sign, and tell Excel that I want it to build a sequence. Open parentheses, how many rows? Let's say we want 15 rows. How many columns do we want this sequence to be in? Well, just one. Where do we want it to start? Well, the smallest possible value of a Poisson random variable is 0. So we want it to start at 0. And then what is the step size? What is the increment? Well, again, all our special discrete random variables, they take on consecutive integer values. So the step size will always be 1, right? And that's our sequence. And let's see, there we go. So because I'm starting at 0, that's why it goes up to 14. If I wanted it to go up to 15, then I would have to say, give me 16 rows, right? Starting at x equals 0, right? But this is sufficient to demonstrate the use of this particular function. Now, suppose I wanted Excel to give me the associated probabilities with these possible values of x. So like I want to know what is the probability that if a random variable is Poisson with a lambda of 5.45, what is the probability that x is equal to 0 or x is equal to 1 and so forth, right? Well, so let's look at what that function is in Excel. So we go up to our formula bar, equals, and it's simple. There's no abbreviation in this one, at least not in the name. It's Poisson period dist, right? So Poisson distribution, open parentheses, and there you go. And you see, it only asks for 3 things. The x that it's referring to would be the x's that we just generated in column A. So if I want to find the probabilities associated with all of these 15 values, then I have to tell Excel to look in column or in rows A3 through A17. So I can enter that range, or you could do your click and drag. I just prefer to type stuff in. So A3 through A17. And what's nice is Excel will go ahead and highlight your range. That way it's visual. You can see that, yes, you've defined the correct range. The mean, well, that's our lambda, right? That's one of the properties of the Poisson distribution, is that the lambda is this average rate of occurrence, right? In this case, I'm using a 5.45. Right. And again, so if for instance we were relying on the table, that comes with our textbook, we wouldn't be able to use a lambda of 5.45, right? And then the third input is, as usual, do we want it to be the cumulative values or the exact values? So in this case, for the PDF, we want it to be exact. So we say no to cumulative. It's a Boolean input, either true or false or 1 or 0. So I'm going to put a 0 that indicates no, I don't want the cumulative values. And it's going to give us the exact probability that x is equal to all of these. Hit enter, and there we go, right? So you look at these, I mean, there's nothing like that kind of jumps out, but you do see that it starts out pretty low, relatively low, not insignificantly low. And then there is an increase in the probabilities, and the highest it gets is to 0.172145763, and then it starts to taper off. And that seems about right? You know, if on average we would expect 5.45 occurrences or events to occur in whatever interval what we're talking about here, then yeah, it seems reasonable that we would expect these events would be the most likely. And then once you go further, once your x value increases, then those probabilities will decrease, right? So again, with the Poisson, much like the negative binomial and the geometric, because those are countably infinite random variables, we can't list the entire distribution, just the portion that we would need, right? Now, if you just wanted to generate a whole bunch, Excel could do that, right? We have the capability for generating a lot. But in the problems that we're likely to be asked, you know, maybe going from 0 to 20, 0 to 30, maybe at most, is what you would need to be able to do, right? Now let's look at generating the corresponding CDF values. Same function, right? Again, click on the cell with that corresponds with the smallest possible value of x, right? And we're going to do is equal to, and then we have our Poisson, right? Period distribution. Oh. And then we set, okay, well, what are the x values here? Well, our x values are in, again, A3 through A17. And what is our mean? Well, the lambda, again, is our 5.45. And now do we want it cumulative? Yes. So now we again, use the Boolean option of 1 for true. Close the parentheses, and there we go, right? Now, again, we haven't captured all the possible values of x, but look, up to 14. So this cell entry here is saying that the probability that the number of occurrences that we observe, the probability that that number is less than or equal to 14 is 0.999453702. So that's very, very close to 1. So even though this distribution allows for any non-negative integer number of occurrences, by the time you get to 14, you're past the 99th percentile, you know, of this distribution, because you've accumulated over a probability of, you know, 99% or higher, right? So it's one of the interesting things about these countably infinite distributions is that they say, yes, anything is possible, but only a few things are really practically likely to occur, right? And that's it for the Poisson, right? So with this video, hopefully it you know, you find it useful and you try it out and you see that we're no longer limited by what values that are in our probability tables, right? So have fun playing with Excel. See ya.